In Module 9, we're going to learn how you can divide your code into separate files and still have it work together to form an application. These separate files are known as code modules or script modules. The modules are a great way to organize functions and classes that are going to make up your program, your application. We will also see how you can inherit code from one class to another. You've already done a little bit of this with creating a custom class for your exception handling. But we'll take a look at another example where we inherit code from a data class. In addition to that, we'll take a look at how you can draw out or diagram the relationship between classes using something called the Universal Markup Language, UML. And finally, I'm going to point you to some resources on how to work with the command console to upload your code files and synchronize your code files, download them from GitHub. We'll be using get from the command line. You'll learn how to do that in the assignment. First on the list is working with modules. So modules are, like I said, a great way to organize your code. You can put functions in there, you can put classes in there, you can put both in there. And it does make your code a little bit easier to read. Typically, I'll create modules based on the separation of concerns. So modules about data, modules about processing, and modules about creating an input-output, a presentation layer. The example I've created here in listing 1 shows a function I just called standalone function. You'll notice that it doesn't have a attribute there for static method because it's not in a class. It's just a function standing outside of a class. I also do have a class here. In fact, I have 3 of them. One class for data, one class for processing, and one class for presentation or I/O. And inside of the data class, the data class, I have a constructor that's just going to print out something. Normally that would not be what you would do with a constructor, but because I just want to demonstrate that this is being called, that's what I've done. In the file processing or file processor class, I've got a static method called process data. And once again, it doesn't do anything other than present something so for testing purposes. And of course, the I/O method of print data does the same. Now, once I've created this file, I have to create another file to use it. I could run the code in this file, but it doesn't do anything. It doesn't have any action. That's because I've never called the functions in the main body of the script. I've never created an object from the classes in the main body of the script. All I've got is the code for my classes and for my function. This is the way Python works as well. Whenever we're doing something like, well, calling out print, or working with other aspects of Python, we're working with modules that are tied into the Python framework. There's a bunch of built-in modules when you install Python, and what we're talking about here is creating your own custom ones. You can also, of course, go out and download modules. If I were to go out on the internet, type in Python modules popular, you'll see all kinds of ones that are available. Top 10 you must know in 2019. This changes all the time. Certainly NumPy is a really popular one. Panda is a very popular one. Of course, these other ones are as well. We're going to learn how to use something called the TK interface one in the next module when we create our application with a windowed interface. But as you can see, there is a bunch of these. I don't know how many hundreds of them there are, maybe even thousands of them, but there's certainly a bunch of them that you can add on, you can download and add on to the standard modules that come with Python. And this is the GUI interface one I was talking about. When you do so, you gain access to all the classes and all the functions that they put into the module files. And again, what we're looking at in this module, that's how you could build your own. These are ones that are already built. Once you know how to build your own, and you start downloading ones that are already built, you'll understand how they're used. So that's the game plan. Now, speaking of how they're used, let's talk about that. The way it works is you have to make another file that imports the code from the module. So to do that, you actually use the word import. And you link that to the file name. Now notice that I don't put the py file here. I don't put it in .py. I don't need to do that. I just need to put the first part of the file name. It's going to assume that it's going to be a py file or even a pyc file, compiled version of it. And there's a couple other options as well. But for our purposes, it's just the file name. Now after that, any code that you have inside of that module can be referred to by putting in the name of the module, a dot, and then the name of the function or class you want to work with. So in this case, I've got a standalone function in there. I'll put a breakpoint here. And start running it. Oops, I want to run it with debug. Okay. And it'll go over to that module and it'll run that code, which of course will print out on called the standalone function. I step into it, it makes a new object. When I make a new object, it calls the constructor, which has the print statement, and it prints it out. In this case, I'm calling a static method, so I'm not making an object because file processor and the I/O both have static methods I can call. I just put in the name of the class, so the name of the module, the name of the class, and then the static method I want to call. So it just runs those. So you can see how this is really quite easy to link two code files together. And the second code file you're working with, this listing 2, is the main module of my two files. This is the listing 2 is the interactive module. It's the one that I start up. It's the one I run to get it to work with the other modules and perform actions. Now the import command is the way you connect these files. The file that you use to test it, like my listing 2, is often referred to as a test harness. Now with a test harness, it's just some kind of file that you go through the testing process just to make sure that everything works as expected. It's not supposed to be the final result of your application. It's just a way of testing it. In fact, in some cases, what they do is they will build the testing harness first and then put in like try-catch blocks to verify that the functions do what they're supposed to and return what they're supposed to. If the developer then goes ahead and makes the module, they run it, import the module, they run the code, and if everything comes out as a positive, then that they know that it has been built to the correct specifications. So this test-driven development is popular, but it can be quite, let's see, challenging to get everything just right. Still, the fact is that doing some kind of testing before you even attempt to create your main module, the one that you want the humans to interact with, is always a good idea. Now, the way the import statement works is it's going to look in the same folder as your Python script that you're interactively working with. So the one that you're directly working with, the module is something that you indirectly work with. The way it works is it'll first look in the same folder, and then it'll go out and look at a variable, environmental variable, if it exists, called Python path. Now you can make these environmental variables a little bit different on each operating system, but in Windows, it's basically under the System Properties, Advanced tab, Environmental Variables. And there's actually a bunch of variables that will be built in, including the standard path, where you can put in, like, look in the Python folder, Python version, whatever, if you're trying to find something. Now this is a user variable. System variables are for all users. User variables are for just that one user. I'm logged in as admin on my machine, so that's why it shows user variables for admin. The system variable would be, again, useful for anybody that tried to access the machine. Anybody logged into the machine. And so I would go ahead and set up a Python path, just to make it easy. Make a little folder called, I don't know, Python mods or something like that. And then, once I did that, I'd go ahead and click the OK button, and OK, and finally OK. And then I'd have a variable, environmental variable called Python path. And that way, whenever, if it did not find your module, the file in the same folder as a module, it would still work. So if I come over here and I look at this, I can see that the listing 1 module and module 2 are in the same location. But if I set up a Python path, it will go ahead and look in the folder I would have made for the Python modules. The advantage of doing that would be that you could have many different Python scripts all looking in that one folder for the modules that you create. And one of the cool things about a module is that you can create it once, but use it many times for many other scripts. So you got to be careful how you write it, but if you write it so that it can be used by many other scripts, you can get the most out of them. Now, I do want to note, we do not need to create a Python path environmental variable for this class. I just kind of want to show you how the concept works, because it's an important concept for your future in working with computers. Mac has the same thing. It's just called Mac has the same thing. Let's see, what is it called? I think it has to be Python path, because that's what the Python framework actually looks for. On a Windows machine, you can see the system variables by using the set command. So I come over here to the console window. I can see all the ones on my machine, including like the path. On a Mac, it's similar, it's just print environment. But anyway, again, you don't have to do this for your module this time, in this class at all. Just want you to know that for future. Now, as I've mentioned, the script that you interact with directly is the main module. And although you may not have known it, that's what we've been doing. We've been building main modules. So a Python application is a program is often made up of multiple files. That's a good way to build things. And so you'd end up with a set of 2 or more files. You'd have the main module and then any other modules that you create. In fact, actually, to tell you the truth, we've been using that all along. If you think about it, the input command, the the print statement, that's all coming from somewhere. That's coming from something that's built into Python. So we've been using code that we didn't write that is part of the Python install. And to tell you the truth, it installs a lot of stuff. Like you'll have a database engine already installed called SQLite when you do the installation, and you can interact with it by just importing that SQLite module. So that's kind of fun to do if you're in a more advanced class. But the takeaway from this is often you will have multiple files that will make up your application, and the one that you interact with as a human directly is your main module. Now there's a system variable built into Python. This is not on the operating system, but in Python. That is the underscore name and a double underscore. So double underscore name, double underscore. It returns the name of the file that you're in, unless it's the interactive module, in which case it returns the word main. So double underscore main, double underscore. And you can use this like in this way. You can ask for the name. If you want to just see what the name is, you can print it. Of course, that doesn't do you much good other than the fact it shows you the name. What is useful is to put some conditional logic in here, such as this. Check to see what you're getting back. If you're getting back main, then perform some action. So if I come over here to my listing, even though the name of the listing is excuse me, is listing 3, when I run this interactively, directly, it comes out the word main. Now let me contrast that. I'm going to go ahead and take this code. I'm going to put it over here in module 1. And let's see what happens when I run listing 2, which imports module 1. Now see, the first thing it does on line 7 is import it. And when it imports it, it's going to come over here to line 7 on my first module, listing 1, and print out the name of the file. So because I wasn't working with the listing 1 module file directly, it didn't print out the word main. It prints out instead the name of the file. It only prints out the name main if that's the one you're interacting with directly. One of the things you'll see people do is they'll put this logic together. If you're running this script as the main script module, at that point, go ahead and start importing your various different modules. And if you want to, you can either type in the import statement twice. There's some preference to that. Or you can type it out once and use a comma separated list. It doesn't matter too much, especially at this level. I will tell you though, if it can't find employees.py file or PYC compiled version anywhere, it will indeed give you an error message. So you could also put in a try-catch block in here if you wanted to. You notice that I'm just raising an exception, a custom error message saying that the file is not created. If it is, a file is not created to be imported if I'm trying to import it instead of use it directly. Now, what I mean by that is this. If I run it like this, everything works just fine. Well, kinda. It can't find the files. Let me say listing, I don't know, module 1. There we go. But, so it imported the code and it's fine. But if I take this over and I put this in listing 1, it's going to raise an error message because by putting this in here, and linking it over to listing 4, listing 1 is not the main module. Listing 4 is the main module. And as such, it's going to raise an exception. This file cannot be created, was not created to be imported. So I would not, if I wanted people to not think of my module, my code, as being something that could be imported and used, I could put this code in there. That would help developers know that the purpose of my code, like this, is not to be ran by itself, or is to be ran by itself. In this case, if it's main, go ahead and start working. If it's not main, it's not meant to be imported. Listing 5 shows an example where I've got this checking to see if it's main, this file is not meant to be ran by itself. And actually I should say, so this says I want this file to be a module. It's supposed to be imported. It's not supposed to be ran itself directly. So I go over here to 5 and take a look at this. You'll see that if I try to run it interactively, it gives me that error message. The only way I can run this without getting an error message is to link it to another file. So what you do is in your main script, you put code like this. You put code like this in your main script. And then in the module script, you put code like this, which says this file is not meant to be ran by itself. It's not supposed to be interactively ran. Trying to run this file by itself, not going to work. This one, it is meant to be ran by itself. Check to make sure it is being ran by itself as the main starting point of your application, and then continue on. Hope that makes sense. Interesting enough, Python will, if it knows that you're running multiple files, Python will compile your script files into a binary format to increase the performance. Actually, to tell you the truth, all your scripts are going to be converted into a binary format. It's just that it's done when you run it on the fly. So at the time you run it, it'll be converted into a binary format, and then it processes your code. But if you were to do this ahead of time, in other words, you were to pre-compile it, it wouldn't have to go through that extra step. And that's basically what happens. So if I come over and I look at that same folder, oops, put this back. There we go. Better close these before I run them. If I look in that same folder, I'll see there's a folder called Python Cache. And inside of here, you'll see that these are the modules that I ran at some point in time. And inside here, it's just the compiled version of my code. Now you'll see that the compiled version is a PYC file. When you turn in your homework, you don't need this. If I delete that, everything still runs, watch. But what happens is that it'll immediately make a new one. So when you turn in your homework, you can just turn in your Python scripts. If you got 3 or 4 files, see, I think you end up with 6 files in this assignment. You just copy those 6 files. You do not need to put the Python py cache folder in there with its compiled files, because on our machines it'll do it for us. Like I said, to link modules together, you use the import statement. So here's another module that we're going to put together. This is a data module. And using these modules, I often will separate the code into a data module, a processing module, and a presentation module. And here is a data module. So I've got the class called person, and it stores information about persons. We've seen this one. First name, last name. I have a method called toString. I kind of like to put those in addition to the double underscore string that Python gives you, just because the Python one is ran implicitly in a number of places. This would be only called explicitly, but it's a personal preference. In other languages, we see the same kind of thing, and you might put one in, an explicit one in for the same reason. It's just an option. It also will help me to demonstrate something else in just a bit. So anyway, I've got the constructor and I got the properties. I took out the comments to save some space here. And you can see my explicit version of toString and my implicit version of it. Now, my explicit version, this one here, just calls the implicit one, and that way I don't have to have two versions of the code. That's a good idea to do whenever you can. Because otherwise, if you make a change to one, and they're supposed to do the same thing, you have to make sure you change it in two different places. Now, like I said, I would end up with other modules. This next module is going to be for processing classes. So I have a class to process data to and from a file. I call it file processor. It's got a method to save data to a file and read data from a file. It'll read it from a file and put it in a list. It will take data from a list and put it in a file. Now, I'm going to send over a list of objects. What I mean by that is these are objects, not just a string of characters. These are like a customer object, or a person object, or employee object, or something that has a string method. If that's the case, I can extract out the data from that data class, the object of the data class, through the string method. And I can use either one of these. I'm going to go ahead and just use the implicit one, because if you're using somebody else's modules, often they won't have one of these. So I'll just put that in there, because I know for sure now that this is going to be built in. It's always built into Python. You do have to be careful though, because if you feed my function here a list of objects, and the list of objects is the objects inside that list just have the default version of the double underscore string, and they didn't take the time to override it like I did, it will just return the name of the class, which is the default behavior of the double underscore string method. I can also do other things, such as, do the try catch block to capture the errors and indicate the success of my method by returning true or false that it was successful. We've seen this before in earlier modules, so I don't think I need to read much more of that code. Now, there's a second class in this same file. The second class is my database processor. Now, we don't get into that in this course, but if I wanted to, I could have a database processor to go along with my file processor, and I'd add code to it to process data to and from a database file. Okay, I found a file from another class I do. that kind of shows that. Again, we're not going to really cover this, but you can see that I'm using the same kind of code here in my little data processing module. It's going to import this database engine I told you about that's built into, that comes with the Python install on both Mac and Windows. And then I'm going to be able to connect to the database file, give it the name of the file, create tables, put data into it, update data, delete data, select data, printing it out. This would be a way of interacting with a database. What I would do is I have this main module that imports that data processor and then performs the actions, whatever those actions are. So that is what would go in this class. And that means that this particular module would have multiple classes. One important aspect of working with modules is you really need to make sure you test them. So whenever you're working with modules, since you don't interact with them directly, it's really important to create these little test harnesses and test as you go. So you can see here in listing 8, I've created a new file that imports listing 6 and 7. I can use this feature called an alias to make my typing a little bit easier. So instead of putting listing 6, I can just put D for data class, or listing 7, I can put P for processing class, or my processing classes. These are aliases to the modules themselves. And that way I can just say, okay, I want to, from the data module, I want to access the person class and make a new object. I'm using the constructor. I do that a couple different times for 2 objects. I put it into my list, and I loop through the list to show that the data worked. The file processor class is in my processing module, listing 7. And I can just go ahead and use the name of the module, the alias for the module, name of the class, and then access those static methods to, in this case, perform some kind of action, such as working with, this is reading data from my persondata.txt file. Of course, I have to have a persondata.txt file in order for it to work. There is person data. We can see that we have these 2 values. So if I come over here and I run module or listing 8, I can see that it works to just go through and pull out the data. You'll notice that at the top here, it's pulling the data in from the table, the list object, and each of these are recognized as a person object. It's a person object from the listing 6 namespace. Modules make up a namespace. So the full name of the person class is now the name of the module, the namespace, and the class name itself. When I read the data from the file, and I bring it in here, this particular method returns a list of object rows. And as such, I end up with the list of objects, and of course that method builds the objects. I'm not using a binary file. I'm just using code to create a list of objects and return that. So that means I can just go ahead and loop through it and work with it. Oops. Let's see. This code doesn't look the same as this one. It does. The problem is that it is not understanding the toString, and the reason for that is, let's take a look at this, because I'm sure this is going to happen to people. So the reason for that is I'm walking through. Where am I debugging? Right here. Okay. So let me step in. Gets the data, it makes the file and saves the data to a file. There's only a couple rows, and so that file exists now, and I'm ready to move on to the next one. Now, this is going to read it, and this is where things are going awry. So it comes down here, and it makes my list of objects. It makes it by splitting the text into the row. And see how it's coming back here as a row of, it's coming back as a row of text. So when I append it, it is a row of text, not a row of person objects. That's a problem. Because if I look at this, you can see that it's a list of 2 text strings, Bob Smith, Sue Jones, and then it's a list of lists. That's not a list of person objects. In order for me to translate this, I'm going to have to add a little bit of code. I'm kind of glad that this happened. Small typos are sometimes good. So that's why when it comes down here, it can't find my implicit toString. And if I use the explicit toString, if I use the implicit one, it would just tell you that it's a string because it would print out the name of the class. So what I need to do is I need to put something together to create the proper list. So let's see here. What we're going to do is we're going to make so the row is going to make up a new object. So obj, how about P3 is equal to a person object. Oops, I'm going to put the D in there. And then it's going to be the row, and it's element 0. That's for the first name. And row element 1. Okay, let's try this again. Now this time I want to print out not the row, but the object. I'm not using very Pythonic type. I'm not using Pythonic names, am I? Okay, maybe I should change this over to, let's see, I want to try to use Pythonic names. How about P? I want you to start getting used to that so that when you leave my class, you'll be more used to how people type in code on the internet that like to work with Python all the time. Okay, I think that's going to work. Let's go give it a try. So it does the same thing, and let's see, I'm in. This is the part that does the saving, and I've already seen this, so I'm going to step out. Okay, we're going to move in, and this is the part that goes through and gives us our string, our list of strings, and I've already seen that too, so I'd like to step over. And here's where we're going to actually build our person object. So let's go ahead and do that. So I'm going to come in here and get the person object. You can see now that it is acting like a person object and printing it out. You can see that the row is just a list. It's a list of strings. And it doesn't have that method I made. But when I put it in a P and I build that to a P, then of course I have it. Now if I want to keep this persistent in a table, I'd have to append to my table. So clear that table and then append to it. That would be the way to go. Well, I guess I better show you. So after I print it out, I might go lst table, and I want to clear it out before I get started. So lst table dot clear, and then append the new row, and that way I end up with the table variable up here filled up with data. clear it out, fill it up. Now I'm going to keep this a little bit cleaner, so let's see, I want to bring this back. I want to kind of bring this back to, well, I think I'll leave it like this. I'll update my text file accordingly. I think that makes a good representation of what's going on. Okay, I have modified the code, so this will all appear in the final version, and you'll see the results like this. Now, what I'd like you to do is try this out. So pause the video and go ahead and try this, put those modules together. You're going to have a person class in one module and a file processor class in another module, and then you're going to build a test harness for it. So let's make the file for the data classes, person class. It's going to be data classes, and you put the person class in it. You can just copy and paste the code from listing 6 into that new file. So I'm going to be giving you the listings as part of my upload this week. And you can literally copy and paste this so you don't have to type out a bunch of code. Oops, gets the whole thing. You want the whole thing. Control A. But because we're really looking at how to connect modules, you've already learned how to type this code in. So don't make extra work for yourself. So make a data classes file, put the person class in it, make a processing classes file, put the file processor in there. You can put the data processing class in there even though it doesn't do anything, just as a placeholder. In other words, you just copy the code from listing 7. And then create a test harness, and that's the same code as the listing 8. And then make sure they work. You should get this when you're done. Give it a shot. One interesting thing you can do with classes is you can inherit code from one class to another. Now, this is yet another way you can write code once and use it many times. This is something that a lot of developers do, and if done right, it can save you some serious time. So when you do this, when you inherit code from another class, it sets up a parent-child relationship. And the way it's documented is kind of interesting. You have a parent and a child class, and then there's an arrow that always points to the parent class. Now, I would think that the arrow would point the other way because code would be flowing into the child class, but it doesn't. You can kind of visualize it as a small child reaching up to hold the hand of a parent, and when they did that, their hand would be pointing towards the parent. Whatever the case may be, however you want to memorize it, it is always going to be like that in the industry. The arrow is always going to point to the parent class, and it's going to symbolize the relationship. Now, you may hear classes, the relationships referred to as a derived class and a base class. So the base class is the parent, derived class is the child. Sometimes you'll hear it as subclass and superclass. That's another possible choice. There's actually a few more of these, and sometimes people will mix and match. They'll say, okay, there's a child class and a superclass, or there's a child class and a base class. I try not to do that, but I've heard it mixed and matched so many times over the years that I still do it sometimes just out of habit. But really, these are the pairs that you want to try to use, especially when you're writing something up. Child class and parent class go together. Derived class and base class go together. Subclass and superclass go together. So again, if you're writing articles and you want to keep it professional, try to use those pairs. Now, you can keep inheriting code from one class to another. So if I had a parent class and I made a child class that inherited code, I could then make a child class after that inherit code from that child class, which would mean that this child is a parent. I guess that would be a grandchild, and this a great-grandchild. So code would flow from the parent to the child to the child to the child. It would continue to flow down into the last child. And any code that you added would be inherited. Any code that you added to the chain of these classes, they would be inherited in the final version of that class, the great-grandchild in this case. It's probably easier to kind of see in action. So let me give you an example. First of all, we've been doing this even if it's been unknown to us. Python, and actually many other languages too, have a ultimate parent class that for some reason the industry seems to like to call object. I find this confusing because, when you create a variable and you create an object from the class and you put the object in the variable. So why didn't we just call it like ultimate parent class or like super parent or something other than the word object? That means that we're using the word object in multiple ways. In one context, it's the ultimate parent class that all classes inherit the basic code from. In another case, we're talking about making an object from a class. So for example, if I come over here and I look at that test harness I had set up, we're making an object and putting it in that variable. But the person class itself actually inherited from object. Now, if I'm not using the object explicitly, it's still going to implicitly put it in there. The most base type. Not much of a little indicator of what's going on, but it is that. It is the most base type. This is where everything starts from. The beginning of the inheritance. If you put that in there, it'll inherit from the person will inherit from the object class. If you don't put it in there, it'll inherit from the object class. And if you don't put anything in there, you don't even have to put the parentheses, which is fine. But that means that you're dealing with invisible code. It's invisibly inheriting from the object class. Now, you can't stop that. That's what's going to happen. So some people put it in. Like I'd like to see visible code, and some people leave it out. Doesn't matter much. Okay, you've already seen the person class. You've been working with it. But here's another class I'm putting in the same file. It's my employee class. It could have been a customer class. It could have been anything that was a person, a student class. And it inherits from person. So person has a first name property and a last name property. It has those attributes. It has methods in here, the toString method in addition to the double underscore string method. The double underscore string method was actually inherited from the object class. That's why if you don't put that in there and you don't change the way it behaves, it will just print out the name of the object, or the class, excuse me, the object's class. So we are overriding the original version of that method from the ultimate base class object. Now when I create my employee class, I can add more stuff to what I inherit. So I only got the first name and last name, and all persons have a first name and last name, but they wouldn't have an ID. Employees would have an ID, so what I do is I add on the employee ID. You notice that I'm adding it to the constructor, and interestingly enough, I don't have to repeat the first name and last name code in here. It's going to be implied. So I have a new attribute that I'm putting in there, employee ID, but invisibly through the process of inheritance, I will also have the first name and last name. So I don't have to rewrite the properties. I can just write the properties for my new attribute, and the properties that were part of the person class are already inherited in this class, so I don't need to repeat it. I do want to change the way the double underscore string method works and my toString method works, because I've got three properties I need to print out. I have the ID and the first name and the last name. Now to do that, I'm going to use the function called super. That will call the string version of super, my super class, the parent class. So they're using super and sub, and whoever wrote this instead of parent and child. So I call the super class version of double underscore string, and get the first name and last name. Once I have the first name and last name, I will put employee ID in and add that to my first name and last name. So I have employee ID, comma, first name, comma, last name, comma. And that's what I'm going to return. In other languages, you just keep the link like we did earlier, where I go ahead and put in a call to the string method here, but it doesn't quite, it works differently here, differently than expected. So even if I put self.str like you would in other languages, it doesn't quite work that way. So I'm maintaining two sets of the same code, which isn't the best way. A better way might be, in this case, to make a third function to go along with these, and then put the code in that third function and call it from there, but that's needlessly complex for what we're trying to do. So I'm just going to leave it like this with redundant code. Not the best practice, but it certainly will work, and be maybe a little less confusing than if I had a third method altogether. Now, like I said, the first name and last name are inherited. Any fields, any attributes, any properties, any methods are all inherited. So when I go to import the code from my listing 9 file, I can specify that I want to create a employee object like this. Notice that I'm using an alias for my employee class inside of that module. This is a different syntax than we've seen before. I'm using the from to only import the employee module. Excuse me, only import the employee class from that module. My data classes module. That can be handy if that's the only thing you want. If you don't want to allow this test harness or this file to access the person class, you feel that it's too primitive for anything but a starting class, a kind of point where you get going, like you want to work with customers and students and employees. The person class has got the basics, but it's not enough to really do much with, because I'm missing things like IDs and emails and other things. You might just import only one of the classes in that module. This is the way to do it. If you're going to import everything, you can just go ahead and, just like we've been doing, put in import listing and then put an alias on there. But again, notice that in the constructor here, I put in not only the ID, I also put in the first name and last name. And that's kind of interesting, because in the constructor itself, all you see is the employee ID. The first name and last name are there, they're just invisible due to inheritance. In other languages, you would have to write those in as well in the parameter listing of the employee constructor. But in this one, it's automatic, like so many things in Python. Other than that, it's pretty much the same as before. We just take the objects and put it into a table and print it out. And down here you can see where if I'm saving the data to a file, I make an employee data file, I can then go through and save that data to that file, or read the data from the file after I save it. And once again, you see this code that I had to add in the previous demonstration, where I go through and I clear out the list and then just append that in. In this case, you can see that I'm actually building the employee object on the same line that I'm appending it to the list. And it just saves me some space. So what I mean by that, so I got back over here. Okay, where were you? 6, 8. Over here, I went ahead and made 2 lines where I made up a person object and then printed things out. In this example, I'm making up an employee object right there on the fly as we pull the data in from lines of text in the text file. Just different ways of doing it. in the end, it all works just fine. That's one way to get this to work. I just noticed that there's an extra carriage return here. It has to do with that part where we've got to strip off that white space at the end. And actually, I tell you the truth, I got it in a couple of files here. Let's see, where's 10? Here's 10. Same thing here. I need to add that to my text. Oops, hey, get back there. You got to watch for these tiny little things. By now, you guys realize how difficult that can be sometimes to get everything just lined up perfectly. Notice that we are seeing that it is a employee object when it prints out the type. So we're building an employee object, and that's indeed the type it is. I'll update the text file here in just a second. Okay, with that update, that'll give you the results. Like I said, I must have reverted it back to an earlier version by mistake. Oh, I don't know. I don't know how these things happen, but they do. You just move on with your life. Anyway, we're going to try it out here. Once again, you can just copy and paste the updated code. That's perfectly fine. And we're going to modify our data classes file to include the new employee class. And then we're just going to test it. So you still want to test the employee class and the file processor class in your test harness, and just verify that everything's working together as a unit. So pause the video, give it a try, and then once you get it working, come back and we'll continue. It'll end up looking the same as this. Next, let's talk about UML. So I said universal modeling language. It's actually unified modeling language. It's a standard way that people diagram the relationship between the different components that make up your application, whatever software that you're creating. There's actually a bunch of different diagrams. I just want to look at 3 common ones that you will come across and may use. If you go out to the internet and you want to find out more, just type in UML, or better yet, type in Unified Modeling Language, and you'll see there's just tons of these different images that talk about different ways you can describe the relationship between the components of your class. Notice that all these look a little bit different, so there's not a complete agreed upon version that everybody uses exactly the same. But you will see, like this is in German, but you'll still see a lot of similarities between all of them. So let me show you again what I've found useful in my career. The first one is the class diagram. This one's a pretty common one. Notice that I've got the arrow pointing towards the parent. So if I had a person class, I would list out things like the properties and the methods. And I would then put a child class together, and the property and the methods. I would not show that first name, last name, and toString were inherited any other way but by using the arrow. So I know because of the arrow, because of inheritance, first name and last name are going to be in the employee class along with the employee ID. I also know, because toString is listed here, that is going to be overridden. So this is going to be a different version of toString than the parent string. So if you have any methods that you're going to override, you would list them as well. Sometimes you'll see people list the constructor, but typically, not always. Typically, I'm not sure. There's a lot of variety. But certainly the properties and any methods that you would override would be listed in here. Now I might have another child class after that. Let's say I had temporary employees. You know, the difference between a temporary employee and a permanent employee is temporary employees usually have an end date. So I put an end date in the the temporary employee class as a new field, and of course I would have to override the toString method because now I'd have employee ID, first name, last name, and end date. And so this diagram would show the relationship, the parent-child relationship between these different classes. Another one that's really popular is a use case diagram. You put a little stick figure together. This is the actor, and then you identify the various different components that make up your system. Now, system and actor are generic terms. System is just the overall application or set of applications that are going to perform some kind of task. Okay, it could be pretty much anything. And the actor can be anything as well. So sometimes you have software that works with other software, and even when that happens, you still use a stick figure. I'm not sure why, but that's just the way it is. So you can assume that the stick figure means that it's a human, but your assumption may not always be right. It may be that it's another piece of software, and the human works with that other piece of software to actually access this system we see here. So in this case, you can see that the system includes the ability to create an employee, modify an employee, delete an employee, add an employee to a list of employees, save the list to a file, or read the file to a list. All things that would be tasks that could be performed by the system, and probably in this case it would be a human actor that could do those things. A composition diagram is another one that's handy, whereas a class diagram looks at the classes, the composition diagram looks at the objects made from those classes. So in this example, I have an employee list object. That's just a list object that I called employee list. And I have an employee object. That's, again, just represents a employee object made from the employee class. And let's say I made a class called benefits, and I made an object from that. Now, objects will have two basic types of relations. There'll be a composition of objects or an aggregation of objects. So in a composition, the employee list is composed of employee objects. There's a strong binding between these. If you have a list called employee list, but it has no objects in there, what's the point? It doesn't do you much good. So I would say I'd be using this notation, this cardinality location, to indicate that you can have an employee list or you optionally cannot. So 0 or 1. It's at your discretion. You can either make one or not. But if you make one, then you need at least one employee object in there, but optionally many. So to indicate many, you don't use m like you might think. Use n, like to the nth degree. So that's just the common notation that we use in the industry. So this means that I could have 100 employee objects in that list or 1,000 employee objects in that list. We don't know how many are in there. We just know that it's many. Aggregation is not as strong a bond. So with aggregation, an employee may or may not have benefits. So some employees may have benefits, other employees may not. You have to have an employee in order for you to have benefits. So there's always going to be one employee object. That's kind of the core of our application. And if we have an employee object, it's only one, it can ever be one. It's not going to be two employees share the same benefits. It's always going to be one and only one employee. And they may or may not. If it's 0, then they don't have benefits. If it's 1, they do have benefits. In other words, there'll either be a benefits object that's connected to the employee or there won't. And this notation indicates that. So these diagrams indicate the relationship between the objects, whereas the class diagram indicates the relationship between the classes. Let's say I'm creating an application. I'm working with a team of people and I want to discuss my ideas. I might use UML to come up with a plan and go to a conference room, invite some fellow developers in, maybe some testers to kind of give me some pointers of things I might have forgot, and just kind of come up with some diagram on the whiteboard. So I might start off with planning it and saying, okay, I'm going to have a human, that's the actor, and we're going to build a system that allows the human to create employees, modify employee, and delete employee data. And that employee data will be in employee objects that are part of a list of employee objects. So we'll be able to add a employee object to a list, and if the actor wants to, they can either save the list to a file, and if they did save the list to a file, they can read it back from the file when they want as well. Now, in order for that to work, I'm going to need another object. I'm going to need an employee file object in order to save data to it or list data, bring data from it. I'm also going to need to have a list object that I can interact with. So when I create a new employee, I should put it in the list. If I call the add employee to the list, I should be able to do that. So I create this, call this, put it in there, and then once it's created, I can modify it by just referencing it in the list. So I guess I could also modify it after I create it if I haven't put it in the list already, but I want to be able to interact with the list by creating, modifying, and deleting any objects in there. And of course, the process of creating an employee involves creating some employee data. So that's another component of my system, my application I'm trying to build. So just gives me an idea of what is going to be involved with creating an application. And I might just sit around and talk with people and see if they can find any holes in here. And if they did, I just redraw it. Now, after we talked about that, I might start identifying the different classes that I want to interact with. So I might say, okay, I want to have a person class first. That's going to be what I'm going to inherit from. That's going to be my base class. And then I'll have some derived classes, like maybe in this case, the employee class, and add on, additional features, different attributes. I also need my file processor to interact, saving data to the file, reading data from the file. So I'd go ahead and list that out. The file name will be a property, read the data from a file, save the data to a file will be my methods. And I want to also put together an I/O class that allows me to print out a menu of options or items, and then to input the choice from the user about which option they want. Another way for the user to input employee data, and another method here to show the current items in the list, things that you should be familiar with now. So these would be the 4 classes I would start off with. I'd make these classes, and again, I'd ask for comments about, does that look right? You might say, I think that this should have been print menu options instead of in print menu items. That might be, something that might improve my code. And that would be, that's what I'd be looking for. I'd be putting this on the whiteboard. I'd be asking for opinions about, what can make it better. And I would probably go on to just describe the relationship between the objects, such as there's a strong relationship between the list object and the employee objects. I mean, if you have an empty list, it doesn't do you much good until you start putting stuff in it. I can put many employee objects in that one list. However, I want an I/O, an input-output class that interacts with only one employee list at a time. So there's going to be one I/O, input-output presentation component object, and only ever one. There's not going to be multiple of those. If there's only one and ever one, you can actually just make a class and make it static. So because you're not going to be making multiple instances of that class, you can just use static methods, and that's what I'm going to do. So all these print methods and input methods are going to be static methods because I only need one and never more than one. And I can have that stand alone, although it doesn't do me a whole lot of good. I would say, let's see, I can have the I/O on its own. I can have the list on its own. But they really need to be connected. So can they stand on their own? I might actually have to fill that in and say that that's actually a component of that. But wait a second. It's not actually a component of it. Employees are a component of employee list. This is actually something I work with. So this is an aggregation. It's something that is connected, but it's not made up of employee objects. Okay. So that means I'd leave it like this with aggregation. And I'd say that there's only one list at a time when my software is running. I can't have 15 different lists with different sets of employees in it. There's only ever going to be one employee list object. And as far as the file processor goes, once again, I'm just going to go ahead and make it one and only one that ties into it. And as such, these functions, these methods are going to be static. I don't need to make object instances of the file processor. And this diagram would tell me that. So once I kind of got feedback from the people in the room, I would then be able to go back to my desk and start coming up with some code for it. So like here, I've created a module for my I/O classes, and I import data, the employee objects, because I need to use the employee objects from my data class module. And then I go ahead and make my employee input output. If I might have a student input output or a customer input output, if this application got bigger and bigger. So I'll go ahead and name it employee I/O input output because of the kind of defines the tasks that I'm going to perform. And because again I only need one of these in my application, I'll just make the method static. So we're using these as directly from the class. We're not making objects first. I make up the menu. I've simplified the menu. It's only four options. Exit the program is an option. So you can show it, you can add, you can save it to a file. The read from file will be when the application starts up. And let's see what else. Oh, input methods. We've seen this before. And lists the current employees. I just loop through there, getting the first name, last name, employee ID. Input data, I get the employee ID, first name, and last name. I want to make sure I strip it off because humans have a tendency to add extra stuff. And then I make an employee object with that item. And I'll return the employee object when they call it. Now notice I'm not putting it in a list yet. I'm just returning the employee object. So later on I'll have to put it in a list object. And remember that if I come back over here and I look at my diagram, that employee list object is separate from this class. And that's how I know I need to do that. So I then go through and make up a test harness. Now we've already tested the data class and the processing class, but we still need to test the I/O class, one I just made. If I was just testing one of the classes in there, and once again I'd use the from that I/O classes module, import the employee I/O. Not the student I/O, not the customer I/O, just the employee I/O. I give it some kind of alias, you just make something up. And then I use it. I come over here and I make objects up. And now I have a list of objects. And then I go and I save the data to a file, read the data from a file to prove that they work, go through that loop process that we've talked about. And then we get down to testing the I/O. Now notice that I'm still testing the data module, I'm still testing the file processor module. I want to make sure that that is all working together with my IO classes. I think it's important to make sure everything works. However, you could of course comment out a section and test only that. But the important thing is you have to test. You have to test. So I would go ahead and test out each of the methods, making sure that they work. The input works and the output works. Once you have the modules made, I've got my IO class module, classes module, I have my data classes module, I've got my processing classes module. I should have called this module. Once I've got all those modules made and tested, it's time to actually make the main module the part that the human interacts with. Because this code isn't something that the end user is going to work with. When I run this, yeah, it works. It proves that things are working as expected. But obviously that's not an application. So what I would do is I would make my main module. My main module is the one that the human's going to interact with directly. And that's where you guys are going to come in. Your assignment this week is to basically make this main module. We're going to use the same code as we've been doing today in the labs. So if you got those labs working, you're mostly done. You just got to go through and create this main module that the human interacts with. When you're done, you'll end up with an application that looked like the ones from the previous modules, where a menu pops up and they can, when the program starts, it loads up data from the file. So you have an employee file, and the employee file, will look like this: ID, first name, last name. Next, you'll show the user a set of options. You'll have a menu. The menu will look like this. Next, hey, where'd you go? Next, you will let the user add data to the list of employee objects. So you have to call the method that allows the data to the human to interact, input an ID, a name, first name and last name. And finally, you need to have a way to save the employee data to a file and exit the program, or actually I probably should separate these. Let the user exit the program. Because that's our 4 steps. That's better. So not a lot of coding. It's really just putting things together, making sure you understand how things interconnect. So that's what I want you to do. Now, what I want you to do is create that test harness. You're not creating the main module right now, but you are creating this test harness that in lesson 12, and prove that that works. Because by doing that, you've gone a long way towards getting the assignment done this week. And the assignment this week is going to challenge you to understand what's the difference between a class and a module. What is the main module? What does that double underscore name system variable do? How do you use it? How do you connect one module to another? What is a class inheritance? And what are the 3 types of URL diagrams? Those are the things I want you to think about and answer. And then, like I said, when you come over here, let's see here. Come on. Let me go back to, give me a second. Okay, here we go. So when you go over to the assignment, you are going to watch some videos. This is going to talk about modules again. It's a good video. It's going to give you kind of a different look at it than the way I have described it, and I think that's always useful. A good actually set of videos out here from Corey Schaefer. And then you're going to read some about the different modules and how they work with each other. Chapter 9 actually has information about this as well. It can become a little confusing. That's what I've been told. I think it's pretty dense. So if the first 8 chapters, we've already covered the basics. We're moving into some advanced stuff. If you're having problems with reading that chapter, you can skip over it for now and come back to it later on after you watch the videos and read the web articles, etc., if you want to come back to it. To tell you the truth, with this video and the articles that you're going to see, you got enough to get the job done. And then you create your assignment 9, you create the project, you make these 6 files, the data classes, processing classes, IO classes, test harness, and the main, along with the text file for the employee data. And remember that I've given you all the code except the code for the main. You've got to connect it all together in your new subfolder, put everything together, assemble it all together, and then put in code in the main module to make it work like a real application. So I've kind of given you a list as a little checklist to help you out, and even given you the listings. I hope that will help a lot. Then once you've got it done, make sure that you include error handling, put the pseudocode in there for you. Run your script in both PyCharm and the command shell. We just had an example of a student who their code was running in PyCharm, but it didn't run in the command shell, and that's because there was an extra carriage return in their text file. You would think they would be exactly the same, PyCharm and the operating system shell, but it wasn't. That was a great example of one of the rare times where it's not. Now, I've been having you document your knowledge for 8 modules now. If you've been doing that, then you know enough now to understand how it works and how people make documents, help documents, how people post these documents on the internet that you find and you use. If you want to continue doing that, you can, but it's going to be optional. The reason why I'm making it optional is because, well, many people by this module are getting behind and they need a little bit of extra time to get caught up. So we're not doing nearly as much in this module or the next module to give everybody a chance to finish things up. Also, this is going to be true of doing something with get this time, but I do want you to learn about it. So learning about it is not optional. I want you to go out and watch this video. It's actually really quite good. And read this web page, getting started with installing Git. I think you should understand that. It's kind of interesting. For these videos, we're using Mac, and most of the course we've been using Windows. So this is kind of, for my Mac users, this is kind of a breath of fresh air. For my Windows users, it's like, what's going on? Because some of the commands are different between PC and Mac in the command shell. And you can ease that transition by installing a command shell called bash. It's what we use in the Unix Linux world. We can have it on our PC as well. If you download the Get for Windows, it'll include the Get bash, and you'll be able to kind of follow along in the video a little bit better if you want to. Now, I want to make you aware, I do want you to watch the video, understand what's going on, and get a good idea about the principle behind this. Because if you proceed on to our UW Python certificate, they expect a lot out of you. They expect to just start running right from the beginning and start using Get. So it's going to be important for you to understand it, or at least seen it once. When you get there, you're going to be forced to use it at that point in time, and you can use it the way they tell you to. So you don't have to upload your files to GitHub using Git. If you're taking the Python certificate starting in winter or whenever, I would recommend you play with this. But if not, you can save some time. So I also recommend that you just go ahead and make the new module, Module 9, using the GitHub website. That's a little bit easier to start off with, although you can do it from the desktop command console as well as the website. I just find the website a little bit easier. But then once the website's done, and you've got the repository made, I should say repository using the GitHub website. So once the repository is created, then you want to use the Git command console to interact with that repository. And basically you'll download files and upload files as you learn how to work with this. So it's actually really kind of interesting how this works, and it is the way that developers nowadays interact with it all the time. They also interact with it with other development pieces of software like Microsoft's Visual Studio, or other development environments where they connect it, like PyCharm. They connect it to GitHub so that you don't have to use the console. But, like I said, this is good for you to know. When you're all done, just submit your Python script. If you've made a Word doc, I said scripts, excuse me, scripts. If you've made a Word doc, go ahead and upload that too. Again, it's optional, but we'd love to see your work if you do, and submit it. Let's see here. If you've made a GitHub repository, we'd love to see that too. So go ahead and include the link to it so we can find it. Otherwise, your hard work will go unnoticed. I've given you a few extra bonus points if you go through the process of doing this, but I only made it like 10 extra bonus points so that people wouldn't feel obligated to get those final 10 points, because they really don't mean that much in the big scheme of things out of our 1,000 points per the course. That's it for this one, and hopefully you will find that an enjoyable task. Happy studying, and I'll talk to you later.